Okay, you could do this question much faster by applying rule number 1. So you get 1 over 32 to power 2 over 5. And then you do 1 over 5th root of 32. Obviously, you have to put that into bracket of 2. Rule number 6, because your n is 2 and your m is 5. So you know that 5th root of 32 is 2 because why? Because you go in the root, you go 2 of them 5 times. And it's 5 of them. So because it's that 2, so you take out the 2 that was common 5 times. So you're going to get 1 over 2. But the squared is there. So you put the squared at the bottom. And that's 1 over 4. So the answer is 1 over 4. Now, that's an easy question to do, but it looks complicated, but it's not. First thing to do here is to get rid of the negative power. Turn that negative power into positive power. So that will become, so for 27, it's going to be 1 over 27 to the power of 1/3. So I've got rid of the negative power. And I'm timesing that by 9 to the power 3 over 2. So I'm going to write it on this side now to carry on, so I have more room. So I'm going to write it properly as 9 3 over 2 divided by 27 to the power 1/3. So that's what we've got. Now, in the power, the fraction, the denominator of the fraction tells you that the number that you're working with is actually 2 numbers you can multiply together. They'll be the same. They'll give 9. So we know what that is now. So that'll be 3 squared to the power 3 over 2. And likewise, the denominator of the power fraction is, the denominator of the power fraction is 3, and it's telling you 27 has a number that could be multiplied 3 times, same number, and then get 27. So that'll be 3 cubed to the power 1/3. In this case, what do we need to do next is basically, take the power of the inside the bracket out. That's the best thing to do. It'll be 3, 2 times 3 over 2 divided by, you could put in the bracket if you like, 3 again into bracket, 3 times 1/3. Right, so now the 2 in the power of it at the numerator, the fraction power times 2 will give you 3, because 2 will cancel out. So you're going to get 3 to the power 3 to the power 3, because the 2's cancel out. And at the denominator, the 3, we get to the power 1, because 3 cancels 3. And so applying rule number 4 will be 3 to the power 3 minus 1, and that will be, that should be 3 to the power 2, and 3 to the power 2 means 3 times 3, which equals 9. Right, this is another question. So the best thing to do in this case is to again get rid of the negative fraction power. Turn that into positive fraction power. That would be the best thing to do. So what rule are we using here? We are using rule number 1 or rule number 2. It depends on the way it's written out. So rule number 1 in the reverse. So I get my 1 over 4 to power 4 over 25 to power 3 over 2. Of course, I'm timesing it by 8 over 27 to power 1/3. Okay, so you're not doing much, but what you're doing next is just write it properly now. That will be, right, so 8 over 27 to power 1/3 divided by 4 over 25 to power 3 over 2. Again, just if you're looking at the powers, the fraction powers, the denominator of the fraction power, the 3 here is telling you that the numbers in the bracket can be written as a number that can be multiplied 3 times to get this number 8 and 27. And the 2 here is telling you the same thing, the same story. Those numbers in the bracket, you can multiply them twice to get 4, and also a number to multiply twice to get 25. So we know what those numbers are. So for the numerator, we do 2 to the power of 3 over 3 to the power of 3, and the bracket is 1/3. I'm dividing that by 2 to the power of 2 over 5 to the power of 2, and the bracket is 1 to the power of 1/3. 3/3, sorry, 3 over 2. So, in this case, what we now need to do is basically take the power 3 in the bracket out. We'll take the power 3 out in the bracket from the numerator and the power 2 in the bracket of the denominator. So we're going to get 2 over 3, and that'll be 3 times 1/3, and 2 over 5 at the denominator, and that'll be 2, because we take it out of the bracket, 2 times, because it's common to both of them at the denominator, 2 times 3 over 2. So in this case, we would have 3 times 3, 3 cancel each other, 3 over 3 times 1/3, 3, we cancel each other. So we're going to get 2 over 3 divided by 2 times 2/3. The 2, we cancel each other there. So you're going to get 2 over 5 into bracket 3. And that's to bracket 1. And that will give us 2 over 3 divided by, well, 2 to the power 3 is 8, because that'll be 2 to the power 3 over 5 to the power 3. So that will become 2 over 3 times, I'm going to flip turn the divide into multiplication, so that will become 5 to the power 3 over 2 to the power of 3, and that will become, now 5 to the power of 3 and 2 to the power of 3, that will become, well, the 1, 2 here, this 2 to the power of 1, so I'll get 5 to the power of 3 over 3 times 2 to the power of 2, because the 2 on top will cancel the 2 at the denominator here. So I'm going to get 125 over, now 4 times 3, 12. So that will be the answer, 125 over 12. Right, that's another question. It looks kind of challenging, but it's not. Again, remember the denominator of the fraction tells you that the number in the brackets can be written in a way that you're going to get might be able to be written in a way that you can multiply themselves 4 times and look out for those numbers. Likewise, the 2 here is also doing the same thing for that bracket as well. So first thing we need to do is to get rid of the negative fraction, turn the negative fraction to positive. So why don't we write this thing here? Okay, so that's 81 as it is to 16. So we're not touching that one, we're just leaving it as 3 to the power 4 fraction power 3 over 4. And then the 9 is going to become 1 over 9 over 25, 3 to power 3 over 2 to power, that's the fraction. So that's what we need to do. We need to turn the negative fraction into positive fraction. Rule number 1 over rule number 2 is what we're using. So in this case, it's rule number 1. We're taking it back to the opposite way. Now we need to write this properly. So that will become 81 over 16 to power 3/4 divided by, so that's what that meant now. So we're dividing it by 9 over 25 to power 3/2. Now the 4 tells us that 81 as a number can be multiplied 4 times to get 81. So I'm thinking it's 3. So that will be 3 to the power 4, and 16 will be 2 to the power 4. So watch out for that, because that's the clue to the question. So that will be 3 power of 3/4 divided by 9 over 25. The clue to the question is a 2 in a power, fractional power, which is 3 squared over 5 squared. And that will be to the power 3/2. Now we need to take the power in the brackets out. It's the best way, just take it out, and you're going to get 3/2 to the power 4 times 3/4. And you divide that by 3/5. We need to take the power in the bracket of the denominator, which is 2. We take it out, so that will be 2 times 3/2. So the 4, we cancel the 4, and the 2, we cancel the 2. So that's good. So we're now left with 3/2 to power 3 over 3/5 to power 3 as well. Right. So now what we now need to do is we could basically open the brackets, and that would be we could do 3 squared over 2 to the power 3 divided by 3 cube over 5 cube. Remember, we need to turn the divide into multiplication. So we're going to get 3 cube over 2 cube times, we have to flip the denominator when you turn the divide into multiplication. So that will become 5 cube over 3 cube. So luckily we didn't multiply out the 3 cube because the 3 cube cancels out. 3 cube cancels 3 cube. And that will give us 5 cube over 2 cube, which is 125 over 8. And that's our answer. Right, here's another question. So it says find n or solve for n. So when it says solve here, it means make n the subject. In this case, we know 16 now because the clue is in the 2 here, 2 to the power of n. That means we need to keep everything in the same base. So 2 to the power of 4 is 16, 2 to the power of 4, that will become 2n, and therefore because they have the two bases are equal and there's an equal sign between them, so their powers will be equal, and therefore n equals 4. Here's another question here. Cube root of 27 equals 27n. So what this question is saying is that, again, as a clue to this question, but the clue is actually in the 3 here, in the cube root. So when we rewrite this, it's actually 27 to the power of a half, and that equals a cube, sorry, to the power of a cube, that equals 27n. So we don't need to do much with this, to be honest, because they have the same base. So you got 27 to the power of 1/3 is equal to 27 to the power of n. So you don't need to do anything else because they have the same base, their powers are equal, and therefore n equals 1/3. Okay, with all these questions, remember, when you're solving them, this is asking you to solve for n. When you're solving them, think of these questions as your patient and you're the doctor. Every question is different, so hence you have to read the questions carefully because you don't want to prescribe the wrong prescription to your patient. So here is your question. This question is your patient. You're the doctor. You're trying to diagnose the problem and then prescribe the right prescription. Hence the tools you use to solve it. In this case, I have 100, 1 over 100. The best thing to do is basically 1 over 100 is 10 to the power of 2. And I'm going to make them the same kind of base. So 10 to the power of 2 equals 10 to the power of n in this case. Therefore, 10 to the power of 2 can be written in the negative power as 10 to the power minus 2. And that equals 10 to the power of n. Which means, because they have the same base, there's an equal sign between them. Therefore, n equals minus 2. So that's straightforward. Here's another straightforward question. So this question is saying that 4 over 9 is equal, root of 4 over 9 is equal to 9 over 4 to the power of n. It's asking us to find n. Well, in this case, the best thing to do is not to solve the root, but put it back in fraction. So it's going to be 4 over 9 to the power a half will be equal to 9 over 4 to the power of n. But the 4 over 9 is a bit like inverse of the right-hand side, which is 9 over 4. So this is telling us to basically change the power to a negative fraction. So that's what it's telling us to do, to change the power to a negative fraction. So we can do that by using rule number 1. So that would be 1 over 4 to the power 9 to minus a half. And that will still be equal to 9 over 4 to the power n. So then what I'm going to do now is to invert this, because when you are dividing, you basically turn into multiplication. So that will become 1 times 9 over 4 to power minus a half, and that'll be equal to 9 over 4 to the power of n. So now I can see now that that implies that 9 over 4 to the power of minus a half equals 9 over 4 to the power of n, where n equals minus a half. So that was the difficult bit here, is to recognize that you need to change the turn into negative fraction and then change the 1 over into times. And then you flip the denominator. And that's how to solve that question. Here's another question. Again, it looks difficult, but again, it's not that difficult. So what we need to do now is to change, this is to apply rule number 5, or rule number 6 actually. So this is rule number 6. We need to turn this square root into a fraction. And so that will become 3 to the power of a half in the bracket times to the power of 7 equals 3 to the power of n. We need to take the power of a half out, and then we're going to have 3 a half times 7 equals 3 to n. So then we have 7 over 2 equals 3 to the power of n, and therefore, because the powers, the base are equal and there's equal sign between them, therefore the powers will be equal. So n equals 7 over 2. This is improper fraction. 7 over 2 is improper fraction. So we need to turn into mixed fraction. How many 2 goes in 7? 2. What's left? So how many 2 goes in 7? That will be 3. 3 times 2 is 6. The difference between 6 and 7 is 1. So you go 1 over 2. So the answer n equals 3, 1 over 2. That's a question to solve. And this question is 4 fourth root to power 7 equals 8 to power x. We need to get rid of the fourth root in this case and turn it into bracket. So that will become 8 to power a quarter. I'm just using the rule number 5 there, rule number 5, and then the 7 is still there to power 7 again, and that will become 8 to the power of x. So I've just applied rule number 5 there, rule number 5. Now, what I need to do now is basically take out the power out. So I'm applying rule number 6. I'm going to take out the power, and that will become 8, 7 times 1 over 4. So I've taken the quarter out and I'm multiplying by the 7. That will be equal to 8x. So 7 times 1 over 4, don't forget the 7 is over 1. So if you're multiplying a fraction, you multiply the numerator and then you multiply the denominator. So that will become 8, 7 over 4 equals 8x, which implies that x equals 7 over 4.